Okay, so 10.3, we're still looking at breaking down radicals, and we're going to look at a couple of little properties of radicals, right? So, for instance, the square root of 9 is 3, and the square root of 2 is, or the square root of 4 is 2. If I multiply those together, 3 times 2 gives me 6, right? So, over here, if I do the same thing but multiply them first underneath that radical, 9 times 4 is 36, the square root of 36 is just 6. So, what it's saying is, if I have two radicals that have the same root, and that's important, must have same root, right? If they don't have the same root, then it's something totally different, and we have to do something different. Okay, we'll look at those later. But if they have the same root, then you're allowed to just multiply what's underneath. Okay, you'll also multiply the stuff that's out front. We'll look at more of that later on, but that's basically what's going to happen. So like the square root of 3 times the square root of 5 is just the square root of 15. Once you get here, you check to see if it's going to simplify at all. Okay, here it's not going to, right, because 15 is just 3 and 5. I need a group of 2, and I don't have one, so it's just the square root of 15. Okay, so you kind of just go along and do that, right? So the square root of 21 times the square root of x is the square root of 21x. Again, check to see if it breaks down, right? No group of 2, so it doesn't break down. That's just your answer. Okay? Whenever you multiply, make sure that your root follows. So when I write my answer here, it's the cubed root of 4 times 2, which is 8. Okay, that makes a big difference because the cubed root of 8 can be broken down. Okay, so make sure that you actually write the cubed root because those were both cubed roots, right? So then 4 and 2, 2 and 2. Got a group of 3, 2, so the answer is just 2. Okay, so then division kind of works the same sort of way, right? I kind of already talked about it. If I have a giant radical like this, I'm allowed to split it apart and do the top and the bottom separately. This is a very nice trick, especially when they start to get really ugly. Sometimes it's nice to be able to break them apart, and sometimes we will put them back together. So we will actually use this both directions, or sometimes we break it apart, and sometimes we will put them together, and I'll kind of talk about when to do what. Okay, but again, still have to have the same root. Must have same root, right? Highlight that or something. It's got to have the same roots, otherwise it's a totally different process, and we'll talk about that later. Okay, so for instance here, instead of trying to figure out what fraction multiplies 25/49, you split it apart and do 25 and root 49, which is just 5/7. Okay, not really a big deal there. You can kind of see that already, but on something like this, it's really nice because I can't do anything with it as one fraction because there's nothing that multiplies together to give me x. But if I split it, now I can at least simplify the bottom. So I've got the square root of x over square root of 9, which is 3. So I can't do anything about the top, but I can simplify the bottom, and splitting that allows me to do that. Okay, so same thing all the way through. Cubed root of 8, cubed root of 27, right? Cubed root of 8 is just 2. If you need to, you can still break these down. Some of these we just use over and over and over again, so you'll get used to them. 2 on top, 9 and 3, 3 and 3, right? So 3 on bottom. So you get a 2/3 there. Okay, so now let's look at simplifying radicals that aren't perfect, because so far everything we've done is absolutely perfect. They're perfect squares is what we call them. 25, 75, these are perfect cubes, right? Cubed root of 8 is just 2. Okay, so now let's look at stuff that's not perfect, okay? Because we're not going to do any decimals in this unit, so I want you to break them down and give me exact answers. Okay, so something like this, you still break it down, right? So the two numbers that multiply to 72 would be 9 and 8. And then 9 breaks into 3 and 3. I'm going to cross out the ones that I break down so I don't accidentally use them twice. 4 breaks into 2 and 2. Okay, so once I'm here, right, I'm looking for groups of 2 because it is a square root. And you circle every group of 2, not just one group of 2, but every group of 2. Okay, those groups of 2 are going to come out and multiply together. So I've got a 3 out front. Okay, all of your groups come out. I've got a 2 that comes out. Okay, and then I have a 2 left underneath, so my final answer there is just 6 root 2. So whatever's left over just goes back underneath the radical. If there's more than one piece left over, so let's say there was a 3 and a 2, right, I would multiply those back together and put them back underneath the radical. Okay, and then 3 times 2 is just 6. So same thing on everything, on each one of these, so this would be 8 and 3, 2 and 4, 2 and 2. Looking for groups of 3, so I've got one group of 3 there. Okay, I've got a 5 out front, so this 2 that's going to come out is also going to multiply by that number that's already there. So 5 times the 2 that comes out multiplies by it. I have a cubed root. Again, make sure you write down the root because the root is not going to change. And then this little 3 is left over. Keep your work nice and neat, because if it's not nice and neat, you tend to lose pieces, so make sure you keep it nice and neat. Alright, so 10 cubed root 3 is where we end up there. Okay, so same thing on each one, 2, 13. So here there's nothing I can take out because I don't have a group of 2. That's fine. That is going to happen, right? If it doesn't break down, then it's just what it is. Don't write no solution because it's still going to have an answer. This is just an exact answer, and then I would approximate a decimal if I was doing engineering or something. We would change that into a decimal. Okay, if it's got a variable in it, same thing happens with the number. So 32 breaks into 4 times 8, 2 and 2. 2 and 4, 2 and 2. Okay, I'm looking for groups of 4, so there's 1, 2, 3, 4, and I have one little guy left over. So this group of 2, it's going to come out. I'm going to leave myself a little bit of room for my variable here, and this 2 stays in, right? So that one came out, that stays in. So now, same thing's going to happen with the z's. If you need to, write them out, right? You can write all 11 z's, 4, 5, 2, 3, 4, 5, 1. Right? And I'm looking for groups of 4. So there's 1, 2, 3, 4. There's 1, 2, 3, 4. And that leaves me with 1, 2, 3 left over. So I've got 2 groups that come out. So z times z is c squared. Right? And then I've got 3 z's left over. If I multiply those back together, z times z times z is z to the third. Okay? For those of you who prefer computation versus writing it out, you're just looking for how many groups of 4 can I get out of 11? I can get 2, right, with a remainder of 3. So this would be the outside, and this would be the inside exponent. Okay? So I'm looking for groups of 4. I can get 2 groups of 4, so z squared, and I would have 3 left over, z cubed, on the inside. Okay? So now that little back part there, okay, same sort of thing. Here we go. This one's just a little bit bigger, so I've got 9 times 6. 3 and 3, 3 and 2. I'm looking for groups of 3, so there's my group of 3. I've got a 3 out front, leave myself room, and a 2 inside. Okay, 3 goes into 6 twice. I can get 2 groups of 3 out of 6. There's nothing left over. 3 goes into 6 evenly, so you're not going to have any x's left inside. Okay, and then 3 into 8 will go twice. Alright, if you need to, do it like this. 3 divided by into 8 would go twice, with a remainder of 2. So that means I'm going to have 2 y's left over inside. Okay, so let me write that a little nicer. 3x squared, y squared, cubed root 2y squared. Okay, anytime you have a fraction, especially if the bottom is not a perfect square, if the bottom is a perfect square or cube, then it's a little different. But if it's not, and you've got a radical over a radical, you put them together. You simplify, and then evaluate the radical. Okay? So same thing, when you get this big old ugly thing like this, okay, this bottom is not a perfect 4th root, so I'm going to put them together. 32, a to the 8th, b to the 6th, a to the negative 1, b to the 2nd. I'm going to reduce underneath, so this is the stuff back from Unit 7, so if you don't know how to reduce these fractions, go back to Unit 7 and watch those videos, right? So a to the negative 1, negative exponent moves up. I have a b to the 6th and a b to the 8th. I get rid of the smallest. Just kidding, that is a b to the 2nd. Almost made a mistake there. Alright, that was a b to the 2nd power, because that's what it was here. Alright, so I get rid of the smallest, subtract it from the largest. Okay, so I still have that 2 out front. I've got the 4th root. There's nothing left on bottom, so we don't have to worry about it. So I've just got 32, a to the 8th, b to the 4th, a to the 1st. Now, from here, we can't have 2 a's, so let's go ahead and put those together. 32, a to the 8 times a to the 1 gives me a to the 9. Multiplying bases, you add exponents. B to the 4th. Okay, so now we've done all of that. We finally put this together. Now I can take that and break that down. 8 and 4, 4 and 2, 2 and 2, 2 and 2. Right, looking for groups of 4. There's my group of 4. Okay, so the 2 is going to come out, and there's a 2 already out front, so don't forget it. So I've got a 2, and then I'm taking out a 2. I'm going to leave myself a little space. I have a 2 left-hand side. Now let's do the same thing for the a's. So 4 goes into a twice with a remainder of 1. And then 4 goes into 4 once. No remainder at all. So final answer, 4. A squared b, 4th root, 2a. Be very careful that these roots don't accidentally become exponents. Sometimes people accidentally mistake those roots for exponents, so be very careful. Make sure your root is either over or inside this little triangle, right? So you can't write it out front. That would be incorrect. So it's got to be either over the little triangle part or inside of the little triangle part. Alright, so the very last one there, again, this is not a perfect cube. 6 is not a perfect cube. No number multiplies 3 times to give me 6. So I'm going to take this whole thing and put it together. 7 cubed root 48x to the 4th y to the 8th over 6y squared. I am then going to reduce my fraction inside. So 7 cubed root gives me 8. Okay, get rid of the smallest exponent, subtract it from the largest. So I've got 8 x to the 4th, y to the 6th inside. Alright, the cubed root of 8. 4 and 2, 2 and 2. So the 2 comes out, multiplies by that 7 that was already out there. Okay. There was no number left over, so I don't put any numbers back inside because there wasn't any left over. That 4 made those two 2, so it's done. The 8 made the 4 and the 2, right? So then groups of 3 into 4. I've got 1 with a remainder of 1. And then groups of 3 into 6. I've got 2 with no remainder. So final answer there, 14x y squared cubed root of x. Okay? That's it.
Ladies and gentlemen, welcome to